everyone!
I'm David.
I'm Haley.
Haley, I'm pretty excited. We've been talking to some people the last few days, and they were telling us about all this work they're doing. They're taking fly ash and waste products, and they're developing it for compressed soil and concrete, and boy, they're just knocking it out of the park. So, problem solved.
Wrong.
Wrong.
Yeah. So, the concrete industry uses lots of waste products. We use recycled concrete aggregate, we use tires, we use fly ash, we use lots of byproducts, rice husk ash, things like that. But there's still a problem.
And what is that?
There are billions of tons, if not trillions.
Now that's a problem.
Just sitting around in ponds, in piles, in landfills, being buried, being covered up. Think about the leaching. I'm just saying, but...
Yeah, there is that. So we've still got a big problem.
Yeah.
Yeah, we still got that waste stream. And I mean, to the concrete industry's credit, I mean, I've been in the industry a long time, and to their credit, I mean, they've been trying to figure out ways, and I mean, fly ash was an innovation when we discovered that it would, you know, help stop ASR, and it, you know, in dams when we used it, it wouldn't burst, it wouldn't really start getting super strong for months, maybe even a year or two.
Wow.
So that just extended the life. So I mean, we were doing great, man.
Yeah.
You know, we were doing really good, but...
And I will say fly ash is awesome.
Yeah.
But we have to do something.
Yeah.
It's our responsibility as civil engineers to not just bury it, to use it or remediate it in some way. And I don't have the answers.
Well, I think we've got some answers.
Sure.
You know, so we're trying to use more of these things. We're trying to find ways. I think what we're doing here at Intelligent Concrete is we're trying to find ways to combine things to make them more beneficial than they would be by themselves.
Exactly.
So that emerging technologies, which is a little tough to push into the industry, but it'll get there.
Yeah.
It'll get there without a doubt. So your passion is
Sustainability.
sustainability. So tell us how that's going to work out with all this waste stuff. What are you going to do?
Well, I would say the first step is making sure what you're doing is local and you're not using or producing lots of carbon dioxide with gas and using semi-trucks to haul this. Secondly, I would say doing tests on the impact before you act, because you don't know what using 80% fly ash or what, you know what I mean, what that's going to do.
Right.
Not only to water, or not only to the concrete or whatever product you're making, but also to the groundwater, water that runs next to it.
Yeah, all good points.
Even evaporation into the air, that could be a pollutant. So. Right.
Yeah, I really like this idea of local. I'm kind of charmed by that. You know, the less transportation that we use for heavy products saves on diesel and gas, which you talked about, saves on wear and tear on the highways, which saves us from replacing them, saves us from expelling bad gases up into the air from the combustion. So this idea of local, I think, is really kind of an interesting idea. And I think we can do that. I mean, there's challenges to that. It's wonderful to go to Home Depot and buy the same bag of cement that we bought last year, and we know how it's going to work and whatnot. But you've been looking into this. I mean, how far does a bag of cement probably travel?
I don't know numbers, but a freaking long way.
Yeah, because, you know, you have to dig it out of the ground, and then you have to
burn it.
You have to make the cements, you have to burn it at very high temperatures. To move it around, you have to stockpile it, you have to bag it, you have to ship it.
And that's just cement. Think about the aggregate, the water, the admixtures, the SCMs.
Yeah.
I mean, there's probably 6 or 7 different contributing factors that all have to be transported to the ready mix plant and then to the job site.
Yeah, so you know, the more we can do local, I think that'll really help a lot. And you know, at first, maybe it's gonna be hard to find some sources or you know whatnot, but you know, we're all global citizens. We're all world citizens. We've got to look at the big picture.
Yeah, and
Yeah.
it's truly our responsibility to be innovative and to engineer solutions to these problems rather than pushing them off and saying, oh, well, the next people will handle it. Oh, I'm retiring in 5 years. I don't have to deal with it.
Yeah, I think there's some of that for sure, but I like that concept about engineering solutions. I think for me, that's how I feel as an engineer I am. You know, I'm a problem solver.
Yeah.
I find ways to make things happen or make them better or, all right, make them cheaper in a lot of cases.
Yeah.
But even that's not all bad.
No.
So no, I like that concept of local engineering solutions. That's where I think, and in some ways, it's a definition of sustainability. It'll make things last longer
Mm-hmm.
forever and make them recycle back. The theory of pi that will start here and return back to where we started. So universal theorem of pi. So all good ideas. Any other final thoughts for us?
I don't think so. Just that if you're an engineer out there, remember it is your responsibility to innovate and think of solutions. So if you have any ideas, throw them in the comments below or email us. We'd love to hear them. This is a real problem we're trying to solve.
That's right. It's a big problem, and it's going to take a lot of people with good ideas.
Yeah.
But we can get there.
Yeah, we will.
We can get there. All right, thanks, Haley. That was good.
Thank you.
That was good insights on sustainability.
Yeah.
Appreciate that.
Thanks everyone for watching. Don't forget to like and subscribe. Ding that bell for notifications. Go Concrete!
Beat asphalt.